Hello and welcome to chapter 3, block 4. And we're going to have one more block after this. Both will be visualizing data. This one we are going to learn how to open NetDraw, open a file or a main network file in NetDraw, and do some arranging of the sociogram or the graph once it's open. Real quick, I just wanted to share this quote from your textbook. So the goal of graphing networks is to place actors and the ties between them such that those who share a similar pattern of ties are located close to one another in the graph, and those who do not are located far from each other in the graph. So think of a network map as an attempt to locate actors in social space as opposed to geographic space, which we normally do. So think of this graph as social space based on a person's ties. All right, so first we're going to start with opening NetDraw, and to do that, you can either put a shortcut down here from NetDraw, which I did, which is super duper, makes it just a lot easier to get to, or as this shows you, you can open UCINet for Windows. So we'll go open UCINet. I'm going to show you how to do it this way. It's the long way, but it is a way to do it. To open NetDraw, it is the farthest hotkey to the right, and if you put your mouse over it, it says Visualize Networks with NetDraw. So it's a really colorful button. So you click on that, and we get the main screen for NetDraw, which I show you right here. I have up here circled the version. So let's toggle back to the actual program itself. Here it has NetDraw 2.160, and this is the most recent version of NetDraw. Next, we want to open data. So here I have circled the hotkey with just the blank yellow folder. You'll get a pop-up open data file window, and I have this in a red circle because this is what you really need to pay attention to when you go to open a network file. So let's go to the actual program and do this. So we have several options right here. Here's a new worksheet. What we're going to deal with right now is just open a UCINet network data set. So click on the plain yellow folder. We get our open data file. For you guys, the defaults when this window opens will be what you will use, but always make sure, because sometimes computers don't always do what we want them to, but we always want to open a UCINet data file ##H ##D, so we have to have both, but we only need to click on one. We want to open a one-mode network, and this will change when we need to open attributes, which we'll get to in the last module of this chapter. Leave all of this and leave all of this as defaults. And we want to open a file. I'm going to open for you the full network for Omar Hamami, the homegrown terrorist. And I mapped his radicalization process. So we're going to open the search button. This brings us right to the folder that we told UCINet to open. For me, I'm going to go to the main network. And I'm going to go to main network file. This is the actual file. As you can see, it says UCINet system file. You can either double click on it or highlight it and click open. Now it's here. As you see in NetDraw, we open the ##H files. Click on OK. And now we have the full network. And I do have a picture of it here. Sorry about that. So here's the network in a static file so you can look at it. And let's go back to the actual program. See, all the nodes are circles. They all have labels. And the labels come from the people that he knew that I coded. So I coded, for instance, FR is friend, F is family, so F3 would be family member number 3, and there's an actual name for this person that I have in a coded Excel file. Here we have J's, FJ's, JL's. These are all different types of people he ran into. So for me, J's were jihadi brothers. These were people that Omar would fight with or commit terrorist acts with. FJ was an overlap of roles. These were people who were friends and then became jihadi brothers. And then we have JL, which is jihadi leaders. And these are leaders of the group Al-Shabaab, which is the terrorist organization that Omar Hamami went from the United States to Somalia to join and commit acts of terrorism. So this here is the full ego network of Omar Hamami. Notice he is in the middle and he is attached. It's hard to tell because there's so many, but he is attached to everybody else here. But what is one of the first things you guys kind of notice just looking at this graph? You notice we have some what's called isolates here. They're only attached to Omar. They're not necessarily, I'm sorry, they're not isolates, they're dyads because there's two people connected. An isolate would be completely isolated in a network with no ties. But we also see little groups, little subgroups here and here that are really dense, with lots of people knowing all the other people in these little dense subgroups. Here we have mostly family and friend networks. It's not as dense as the jihadi leader and jihadi brother networks or subnetworks. In this case, these subnetworks are by place. And that is one of the attributes, and we'll look at that in a little bit later. But some of the things you do notice right off the bat is these little subgroups, some of them more dense than others. So when you first open a network, one of the things you want to do is click and use to lay out. You use the springboard layout. To do that quickly, all you need to do is click on this lightning bolt and it can rearrange the network. If you click on it, you can mess with this value right here and it will make them farther apart or closer together. And it's however you think is best to visualize your network. I always just keep it with the default 5. Click that button and you can click it as many times. Once it starts really moving around, then you know you kind of got what you need. You can also click, so you click your mouse button down and you can move individual actors around however you want, right? Just so you can get them maybe out of the way of each other so you can see them better. But always make sure you do the springboard because, as that quote said earlier, think of these people laying out in social space. Because Omar has the most ties, he's going to be in the middle of this graph. And as you notice, the people with the least amount of ties, such as S1 and M3 and FR9, he has 3 ties, S1 has 2 ties and 1 tie. These guys are on the periphery or the outer part of the network because they have the least amount of ties to people in this network. So there is some order of semblance going on here, even though it might look like a crazy thing. So just remember to click on this. You can also go here under layout and look around and try the other ones. These are all different kinds of layouts. So let's do a graph theoretic layout and see what happens. I just keep the defaults, click OK, kind of looks the same. Let's do Gower. There's something different. And all of these different layouts are explained in your textbook. It's not something that you will necessarily need to know. You can lay it out by a principal components analysis. If you remember, actually you probably don't remember that from statistics because that's in advanced statistics. Sorry, cancel that. Layout. Anyway, you see there's all different kinds of layout methods and the textbook talks about several of them. For me, I generally, for the most part, use the lightning bolt or the layout with node repulsion, and this value gives you the amount of repulsion. Think of it as gravity, and people with more ties would have more mass, like Jupiter, the larger planet, and so their gravity would be stronger, and they would pull people in closer to them, whereas isolates or dyads or people with a less amount of ties would be more like tiny little dwarf planet Pluto. Their gravitational or their gravity is not very strong, and so they don't pull people in as close, and so they lay farther out from others. Okay, so the next block will be to look at attribute data.